Hello guys, in this video I just want to test the voltage drop across the diode when we connect these diodes in forward bias in a circuit. I have different kinds of diodes here, as you can see. So this one is a regular diode IN4007, a regular silicon diode, and this one is a Shottky diode, is SB245. That's a Shottky diode, and I have a Zener Diode. I think this is like a Z27B or something. That's the number. So I have regular diode, Shottky diode, and a Zener diode. Let's go ahead and connect each diode in forward bias in the circuit and see what's the voltage drop across each diode. So I have a very simple circuit here, an LED and a resistor connected to the positive terminal of the battery, and I have a wire connected to the negative. So we're going to put the diode in between resistor and the ground, and we are using the regular diode IN4007 silicon diode. We're going to connect this in a forward bias, connecting the negative terminal, negative pin to the ground, and the positive to the rest of the power supply. Now the diode is conducting and the LED is turned on. Let's check the voltage drop. Across the diode, I have the multimeter probe here, connecting, checking the voltage across the diode. Okay. My multimeter showing 0.741 volt, which is typical for a silicon diode. That's the voltage drop across the silicon diode, 0.77 volt when we connect in forward biasing. What does that mean? Like, there is always a voltage drop across the diode, 0.7 volt in the circuit. So this is a 9 volt battery. So this diode drop 0.7 volt, and the rest, if it is a 9 volt battery, then the rest 8.3 volt is available between the load. Okay, now if I connect another diode, so this one has a 0.7 voltage drop. Now I'm using a Shottky diode. Let's see what's the Shottky diode do. I'm connecting in forward biasing. Diode conducting electricity. That's the current in the circuit. Let's see what's the voltage drop across the Shottky diode. My multimeter shows 0.26 volt. 0.26 volt. That's the voltage drop across the Shottky diode that I have, meaning the Shottky diode only dropping a very small voltage, like 0.224 or 27. Okay, let's say 0.2 volt, which is much less than a regular diode, which has 0.7 volt. So this has a 0.26 volt of voltage drop across the diode. Then now let's go and use the Zener diode. Let's see how much voltage it will drop in a circuit. So the Zener diode has you can see a black line at one end, that is the negative or the cathode. I'm going to connect this from the circuit in forward bias. Current is flowing in the circuit, and let's check the voltage across the Zener diode. 0.75, just like the other regular silicon diode, the same voltage drop, 0.7, no big difference for the Zener diode. So what we learned among all these three diodes, Shottky diode has least voltage drop across it when we connect in forward bias, and the Zener diode and the regular silicon diode has the same voltage drop, like 0.7 volt across it. So nothing special. Now what I want to do, I'm going to connect each of this diode in reverse bias. Let's see what happens. I'm using the regular diode IN4007, connecting in reverse bias. Nothing happening. Diode is not conducting current because I connected the positive, meaning anode of the diode, to the ground, and the rest of the circuit. So nothing happening. Why nothing happening? Because this diode has a very high reverse breakdown voltage. So in order for this diode to conduct current in reverse bias, we have to apply a voltage more than its reverse breakdown voltage. So it has 1000 volts. So we have to apply at least 1000 volt across this diode to conduct in reverse bias. But of course, it will damage if we apply that much voltage across this regular diode. Then let's see what happens if I connect the Shottky diode in reverse bias. Nothing happening. It's not conducting current. It acts as a regular diode. It's not conducting any electricity, just like that one. So also this diode has a very high reverse breakdown voltage. That's why it's not conducting any current. Now let's try the Zener diode. I'm connecting this in a reverse bias, meaning connecting positive to the ground and negative to the positive side of the circuit. Now the Zener diode is conducting, meaning the voltage across the Zener diode that we applied is more than its reverse breakdown voltage. Let's check what's the reverse breakdown voltage of this particular Zener diode. So the Zener diode conducted current even if we connect it on reverse bias. Let's see what's the voltage across it. So my multimeter is showing, let's go see, 2.4 volt, meaning this Zener diode has a reverse breakdown voltage of 2.4 volt. So this diode will conduct current if we apply any voltage more than 2.4 volt, even if it is connected in a reverse bias. So let's check the voltage. It's like 6.2 volt. So what the voltage we applied is 6.2 volt, and this diode working in its reverse breakdown region, but it didn't damage the diode even if we connected in reverse bias and applied a voltage greater than reverse breakdown voltage, because this diode is designed that way. It is designed to withstand the reverse breakdown voltage. So usually a Zener diode uses a voltage regulator, because this Zener diode keeps the voltage across this diode always 2.4 volt. When we connect in reverse bias, it doesn't change that voltage whenever we connect a load across the Zener Diode. Let's connect an LED across the Zener Diode and see what happens. Positive. It's a little difficult, but okay, there. So there's a 2.4 volt difference in the between those two pins of the Zener Diode. So the LED is turned on. Let's see what happens if I connect this in a forward bias. That's like a now the Zener Diode is in a forward bias. I'm connecting this LED across it. Let's see what happens. Do you think the LED will turn on? The LED is not turned on because the voltage across the Zener Diode is 0.7 volt. The 0.7 volt is not enough for the LED to turn on. So that is it. So now you got an idea of different kinds of diodes. So what we learned, the Zener Diode has a forward voltage, forward peak saturation voltage, 0.7 volt, and the regular diode also has the forward minimum forward voltage 0.7 volt in order for this to work. And the Shottky diode has a much lower saturation voltage in forward bias, which is 0.2 volt. But in reverse bias, the regular diode won't conduct unless the voltage is over 1000 volt. Same with the Shottky diode, it doesn't conduct unless the reverse voltage is so high. But Zener Diode has a very small reverse breakdown voltage. For this particular one, it is 2.5 volt. Any voltage, if we apply any voltage over 2.5 volt, this Zener Diode will conduct even if we connect in reverse bias. So that's all. I hope you guys learned something, and if you like the video, give me a thumbs up and subscribe to my channel if you want to learn more about it. And that's all about it. And thanks for all the subscribers who subscribe my channel. I didn't expect. I have over 300 subscribers now, which is honestly, that's quite impressive. And thank you very much.